Okay. This one? Let's see that. This one. Okay, good. Very good. Very good. Okay. Thank you very much, Zubir, for this nice introduction. And the title of this conference is Renovation Circularity. But since I'm already retired a year ago from TU Munich, I'm a little bit impatient, you know, when once you get older and you become more impatient. Alan knows it, okay? So I think I cannot endure the renovation. I think we need a revolution. And why we need a revolution is because our society has so many problems. I mean, in France, you have the Gilets jaunes and many demonstrations all around the world. There is not enough affordable housing, and even, let's just start, even the infrastructure is not so good. So I want to tell you about the last 40-some years I'm involved in this business, also in prefabrication, where I started from. And I want to show you also lots of my mistakes, because you can learn from my mistakes in order to start a real revolution, which our societies all over the world need very badly. And okay, so as I mentioned, also it's actually related to our society. Like for example, in Europe, in other countries, it's even more, developing countries and other countries is even more. The ratio of investment in construction, infrastructure, and so on in the built environment is about half of the whole investment in Europe. Other countries even more. So once this goes wrong, this investment, or it doesn't happen, we have a problem. And we really have a problem now. When you look around in your cities, wherever you live, it's too expensive, whether you're in San Francisco, in Paris, or in Munich, in Germany, it doesn't matter. So it's too expensive for the clients, it's too expensive for the people to rent apartment, also even for the investors, they don't get enough return on investment. And we even have bankruptcies in Germany of project developers. So something went wrong. So what went wrong? Of course, in my opinion, it's we don't have enough automation and robotics in construction. So I think this is an aspect we have to, or you have to research, because I'm already too old and I'm a retired person. So you have to investigate about this. And also because lots of professors here, we need actually new education, totally new education. Maybe we have to tear down the faculty structure, this department structure, and have to start totally new education system. Because I got 3 different degrees from 3 different faculties or departments. And that's stupid, you know, when you do it sequential, like I had to do it, something in Germany, something in the United States, something in Japan. So, and also the environmental challenges are very, now very hard on us. So even here, this circular economy, robotics can be made affordable for the circular economy and also for the demographics and so on. So let me just show you what my experience was. I also worked in the construction industry, and of course, you're trying to, when you're young, you learn how to get most of it when you work for some company, and even lots of people looking for their own profits and so on. But we have lots of quality defects. And the claim management, and even some professors of my former colleagues, they're even teaching claim management. And I think, what's that? Why you teach claim management? If everything is well planned, well designed, there shouldn't be no claim management, actually. I mean, you know, in the car industry, claim management doesn't happen. So why it happens in construction? We have to really question everything in our industry. So, okay, so let's go on. So what would be the vision? Of course, this is our vision. This was drawn by Dr. Pan, one of my doctorate candidates, because he's much better in sketching than I was when I was his age. So I think something like this should happen. It should happen fast and quickly, and there should be no rework. It should be right first time you build something. So yeah, let me just show you a little bit of my experience. I also, actually first I went to France, and there was a very famous company called Coignet, and they introduced some production method from Citroën. So I got interested also in the car industry, because some construction company making precast concrete panels using some technology from Citroën was kind of interesting. And then I also went to United States, Texas. There was in San Antonio a very interesting company called Zachary. They built the first concrete modulars, and the company was called Concrete Modulars International. So, and they built the first concrete modular building for the A&M University in College Station. So I was all experiences. And then, of course, in Germany, I worked in some companies that did something for the Munich Olympics. And then also in Iran, even before the revolution. And so, and this was going through the mechanization in prefabrication, which is very important. And then, of course, later, while I was in Texas, I heard about Toyota production system and so on. And then the book came up by MIT professor, The Machine That Changed the World, and stuff like this. And they called it lean production and so on. And you know the rest of the story. So, okay, and then I decided to go to Japan, which was really difficult, not as easy as today. You know, you sit together, you know somebody, like here in this conference, I had to write letters, I had to wait for weeks and months to get an answer. It took me 2 years till I got to Japan after I was in Texas, so in Chicago. It was really difficult. And then I checked the Japanese industry, and they already in the 70s, they had these ghost factories where machines made machines, like Yamasaki or Masak. And they had these flexible tool exchanging machines. This was amazing. So I thought, okay, on the left side, you see what I did later when I went to Karlsruhe. I tried to copy or was inspired by this technology to have a flexible tool exchange for some Gainter robots. And this all automatically. And then we built a modular robot system. This was in 1990. Everything was modular and reconfigurable. This was interesting because you have to reconfigure according to the task you have to do. And even the control system we built ourselves, which was kind of risky, but I wanted to control in real time. And this was very important. So we could really control in real time within a couple of milliseconds to have a very efficient real-time control, which could be interesting for digital twins now if you can feed it into real-time control. And then, of course, the German reunification came in 1990. So I produced some robots for prefabrication, for brick walls, which was not so intelligent because when you produce first a small brick and then you produce a wall out of it, it's not so efficient. But the investment in the brick industry was already there. So, okay, so let's do a brick wall robot. And it worked. And also this was controlled by the Toyota production system, the Anton system, as you can see down there in the middle. And so, and all different kind of production system for not just for precast concrete panels, but also for brick walls and brick floors and ceilings and roofs and everything. So we actually had a flexible manufacturing system. So on one production cell, you could produce walls and floors and roofs, whether it's in brick or in concrete, it didn't matter. So this was kind of interesting. And there was a company that produced bricks according to the robot capabilities, which is based on my doctorate. The main chapter was robot-oriented design. So these bricks could be grasped easily by a robot, several bricks, even 3 rows, 4 rows, whatsoever. And then they could also place the pipes inside and the services and for the ducts and the utilities and so on. So it was really fast. And on the left, it's a vertical one, a vertical production. In the center, it's horizontal production. And we already included all the, for the water closet and so on, and the windows and everything. And here you see the one on the left side for the concrete panels. So this was a prototype later produced in big numbers, the machinery. And at the same time, besides my professorship in University of Karlsruhe, we developed the 80,000 German mark house. So it would be like 40,000 euro. And why this? Because those days, the Dutch had a 100,000 guilders house, and 100,000 guilders is about the same like 100,000 German marks or 50,000 euro. So, and there was a reunification, there was a big demand. And 80,000 German mark or 40,000, of course, now it would be more expensive, but according to an upper middle class car. So the goal was upper middle class car, so people can afford it. You could also finance it like a upper middle class car. So, so we built about 5,000 houses, and we constructed them in 8 hours and prefabricated them in 8 days. Therefore, I called it the X8 house. 80,000 German marks, 8 days prefabrication, 8 hours on-site assembly. And everything here you see on the picture up there on the right was done by one flexible manufacturing cell, this gantry, double gantry type of prefabrication robot. And of course, the most advanced is still in Japan, Sekisui Heim, for example, or Toyota Home. Highest prefabrication ratio, and also the quality is perfect, earthquake-proof, whatever you want. And here we did the assembly in 4 to 6 hours, and this was really fast. I mean, I couldn't beat this one. But the real challenge was the construction side. So in the beginning, when I came to Japan, I couldn't speak the language, so I made these sketches. And the idea was to have a very fast return on investment, because huge money is involved in construction and infrastructure. So we need really quick implementation. That's actually the idea of you know, this kind of lean comes actually from the old samurai spirit. The American professor from MIT, I forgot his name, he described it like you have a long, long preparation time. Like the samurai, before they went into battle, they had a tea ceremony, and then they concentrated, and then they got up on this one stroke, they tried to kill the enemy, something like this. So you do it very fast, quickly. Execution very fast, but very, very long preparation time, job preparation, so you don't make mistakes on the construction side. Okay, so some of the robots you know already have been developed. These are some examples from the first 50 robots that were developed in the 80s. You know some of them. I helped in some of them. We needed about 3 cycles to improve one prototype till it became more efficient than the conventional construction method. So you always have to be patient. It doesn't work the first time. So you have to somehow continue, improve. And this is also a problem, because sometimes people give up, and it's too early. So you need a long endurance. It's like the first cars as well, or like the first airplanes. Lots of them crashed. So you need long endurance and go on. So actually never give up. Okay, so what is important, because now I envy you, because now you have great computer capabilities. IT is gorgeous, what they can do. When I was student in the 70s, and when I got my doctor in the 80s, it was still computers not so capable, and it was really, really tough work. What triggered my experience was, or what triggered me to get into more of than the prefabrication, was when I built my own house after it burned out, and I had to do the masonry myself and concrete myself. I injured myself, and I was just 22 years old, and this was exactly the time when I also have seen what's going on in Texas, and when I heard from the Americans what the Japanese are doing and stuff like this. So in 79, it triggered a lot. And then I got into robotics, but I made a big mistake. In 84, I was in one of the committees, and then in the research institute of the building ministry of Japan, Ministry of Construction, called Kenken in Japanese. I had the opportunity to do some tests. I took a FANUC robot, and I developed the gripper and the component to be handled, and the logistics and so on. It worked okay, but the problem was it doesn't work on the construction side. So this is also my message: don't go with the industrial robot onto the construction side. It's easy, it's a quick solution. You can demonstrate some things, but they are too heavy and not suited for the on-site work. So this is also, exactly 40 years ago it happened actually. And then later in France, since we are here in Lille, I got my first job, so-called Poste Rouge for CNRS. I think you don't know him, Professor Coiffet. He was a robotics guru in France those days, and he published many books. He lives now in California. He retired, and he employed me, and we started the first Club Robotique au Bâtiment et Travaux Publics here in Paris, and this was a great experience. We did some robots, and painting robot with CSTB. We did the cleaning robot for the pyramid, also cleaning robot for the subway, metro in Paris, and so on. And all was also inspired by this robot from FANUC. It was the first mobile robot from the research institute from FANUC developed for General Motors. So, but this was too heavy. You see here, this one on the right side is too heavy. So you cannot do it on the construction side, especially not on a floor of some office or apartment building. And later I went on my first professorship. Actually, all these professorships were newly established. They didn't exist before. So we need something new, a new approach. Better is we need new faculties. Maybe we need even new universities, because in the existing structure, I think we cannot have to develop the potential of what we need for the revolution, like I call it now. We need really a revolution. Otherwise, our societies will have some civil unrest if it goes on like this, if they cannot afford their own housing or rent their apartment and stuff like this. So this is actually what we need. And also Zubir is also doing some research of the crane automation and so on. But actually we need also new kinematics. We shouldn't continue only with the existing construction machinery kinematics. And then here also we did the first construction robotic project in Europe, which was difficult because those days there was no budget in the European Commission for construction. So I had to team up with the mechanical engineering people to get into, to tap into manufacturing budget for the research. So I found a professor in Madrid. He was a famous professor, Professor Puente. He was actually doctor father of Carlos Balaguer and Ernesto Gambaro. Maybe you know these two people. And through the manufacturing budget of the European Commission, we developed the first masonry robot. And I couldn't call it even for construction. I had to write down heavy-duty robot for heavy-duty operations. There was nothing about construction, not so much. I hid it somewhere. It's really difficult those days. But then was the breakthrough. After this work was the breakthrough. And also there was no industrial robot to have a heavy payload of 1 ton. I want to handle 1 ton. Because if you do lower payload, worker can do it as well. So 1 ton, and you have 1 square meter to assemble very fast. Because if the bricks are too small or the elements, well, you can do it by conventional machinery. The problem was the construction material industry was not ready for it and was not willing to change their products. So we had to adjust the robot to the product. So the end effector of the robot became another robot to compensate for the inaccuracies of the construction material. This is also a problem. So you need to develop a whole ecosystem. It's like the first car didn't work because there were no roads and no fuel station. So you need a road network, you need fuel stations and so on. And then once you have the whole ecosystem set up, then it works. Then the revolution might work. Okay, and this was the final product. And it was 400 kilo, 600 up to 1 ton. And but it wasn't much applied in the construction industry. And this was really difficult because the ecosystem was not there. So later I moved to Munich. I got a chair, also again a new professorship that didn't exist before. And then we developed the first interior robot. And it was a modular robot inspired by this first robot by Dr. Maeda and Dr. Yoshida, developed in the late 1970s. It was also a modular robot system. You could, you have the mobility, the locomotion unit, and you dock in the working unit, and horizontally modular robot. And I did it vertically. So on top of the locomotion unit, I had different working units for all interior works. So, and also it was lightweight. I worked with aluminum, so it was lightweight. It could It could use any kind of standard elevator. It could enter any door. It was light enough to work also on apartment floors because it was all built by aluminum. It could even crawl up the stairs if there was no elevator. So it was actually construction-oriented kinematics, as you can see on the left, and it could expand about 3.50 meters to do the suspended ceiling works or whatever you need for air conditioning and everything like this under the ceiling. But unfortunately, this was sponsored by the Bavarian government. I could only do one application, and I couldn't do for the whole interior finishing. So again, the ecosystem didn't work. So this is just my advice, and because from the mistakes I made, you can learn a lot for the future revolution. And then, okay. Yeah, this is here, I want to show you on the right side. When I first got into computers, maybe you know Fortran 77. I had to program. It was really difficult. It took about 1.5 years for my diploma thesis, which shouldn't, legally it was not possible because you only can take 6 months, but the professor thought it's kind of interesting. The first time a student did everything with the computer, even I wrote the software, and it worked. And then this was one of the Clue experiences. And then also in Chicago, I had the chance to study under famous professor Franz Lacan, Myron Goldsmith, did the Sears Tower, Hancock Tower, you know those gorgeous buildings. And even Goldsmith used to work for Miss van der Rohe, and he did for Miss van der Rohe, he did the Farnsworth House, Exoskeleton, later the Crown Hall at IIT, also Exoskeleton. So gorgeous engineering architects. And then, wow, and this experience got together, and then I had a chance to work in the Shimizu Research Institute in Echoshima in Tokyo, and first developed the first automated construction system. And from that moment on, we pushed a lot through, and you see the prototype of Shimizu in Echoshima on the left side. And down there, the last one I was busy with before the virus came in 2020 in Osaka. So it was a long continuation, and my task was the joining system of the columns, of the beams, of the facade, and so on. Also, I did some little job for Obayashi, the joining system, which is actually robot-oriented. And then the assembly was really fast. So actually here, this we did very simple stuff, no witchcraft. So it's really working very fast for all the components you need, and even for the pipes as well. Here I copied a little bit from the shipbuilding industry. The shipbuilders, they like in Korea, you have one of the biggest shipyards in the world, and they all do prefabricated modules and also the pipes and the services, and then it's much easier than connecting one pipe to one pipe. You just a whole bunch of it. And so we had about on some sites, there were over 100 robots working at the same time. Well, the last one here you see in the center was in Osaka in 2020, and then the lockdown came, so this was a pity. And in Munich, Dr. Iturralde, he's now professor in University of Stuttgart, where I got my first degree from. He did this gorgeous project, Hephaestus, cable-driven parallel robot. This robot, since I also hold a commercial pilot license in Dallas, I always check the aircraft industry, airspace aircraft industry. That's a little bit of my hobby. And I visited Airbus Industries in Toulouse, and I've seen the cable-driven parallel robot assembling the A380. And I told the people we have to switch it 90 degrees and use for facade assembly. And here we did it. So that's really great because you don't need much space, and you know facade assembly is very critical. Lots of people injure themselves. Some of the panels get damaged, and then you have water leakage and so on. So here, and this can also be used for renovation because the title of this conference is renovation. There was another project before Hephaestus called Bertim. We did with a French company and a Spanish company. We did for the panels, for the renovation of existing buildings that have been built after the war, like in France, Le Grand Ensemble, they have to be renovated. And we did it with south of Paris. I think the company was called Proby, 150 kilometers south of Paris, and the Spanish company was called Eguin. You can contact Kepa Iturralde, you know him, so he can tell you everything about it. And now the last one he is taking care of is called Ensnare. So it's 3 projects in a row, all related to this one. And now he works with drones. So trying to set up the ecosystem. So anyhow, okay, and then the circularity. This is about the deconstruction. Somebody is here from Kajima, Dr. Hu is here from Kajima Kensetsu. And this was actually the headquarters of Kajima and Akasaka. They disassembled slowly. And this demolition site was not a demolition site like, normally, in Europe, we use wrecking balls. In the United States, implosion. You cannot do it in the center of Tokyo. So they cut it down, or Daruma, they called it Daruma Otoshi, and later they had to call it cut and down because of some intellectual property rights of the name Daruma Otoshi. But it was a very quiet demolition site. They cut the ground floor and lowered the building. And while you're lowering the building, on the upper floors, all the interior was disassembled. So 93% of the material of the high-rise could be reused. That's amazing. And it was quiet and fast and cheaper than conventional demolition, actually. Plus, it was no burden on the environment because 93% was recyclable, reusable, and clearly separated into different categories of materials. So you see here, this is the ground floor where they cut it, and it looks very beautiful, clean, so-called demolition site. And the other one building here is across the Imperial Palace. So in the center of Tokyo, very quiet, nice deconstruction. Of course, other general contractors did similar stuff like Taisei, Tekorep, Nishimatsu, and so on. Infrastructure is also bad. At the beginning of this year, I was invited at a big European infrastructure conference, and we have huge problems with infrastructure. We need to repair bridges, our sewage system is leaking. So we need to do lots of stuff. And also I was a member of the Civil Engineering Society of Japan for the automation under Professor Obayashi, those days in the 80s, and this was my proposal. And later, while I was in Karlsruhe, we teleoperated from Karlsruhe 3 different robots in Japan, in Chofu, in Echojima, and at the University of Tokyo. And we did on purpose 2 satellite jumps in order to have a time delay, which was difficult, but we did on purpose to have onboard intelligence on the Tokyo side so the robot doesn't crash. So we tested it. Later, it can be used also for space construction. And here you see one of the implementation. Now it's a commercial product in Japan, as you see in the center, especially for disaster areas. If some earthquake happened or landslide happened, like a volcano eruption in Unsen, this is near Nagasaki, or the tsunami after the big earthquake in northeast Japan, or Fukushima, and in a big landslide also near Kumamoto. And at this construction site, I also consulted for this teleoperation. Actually, here you see me, I'm controlling at the Ministry of International Trade and Industry at the Mechanical Engineering Laboratory. It was called those days. I'm also the first teleexistence robot control. And this experience we used, and also for road construction later. While I was in Karlsruhe, we did this project for the road robot with a company called Vögele, but now it belongs to another company. Doesn't exist anymore. So here you see this idea from the 1980s till about 2020, before the virus came. Now it's many commercial markets, even small companies are using this technology now. So here we also need, and then of course, the demographic challenge. This was also a study I did for the Japan Science Society in the 80s, and actually now we have big problem in our societies, aging societies, not only in Europe, but also in China will be a big challenge. So we developed some modules for interior refurbishing so the people can stay at home, and the prefabrication of the interior module will help that they don't need to move to a care home, because old people don't want to move. There's a saying in German, I don't know the English translation, you shouldn't transplant an old tree or something like this. I don't know whether this makes sense in English. Anyhow, here we have embedded sensors. It's actually a mechatronic interior system, or mechatronic or robotic interior refurbishment system. We can catch the health data of the people while they are sleeping, sitting, or cooking their food, or taking a bath. We can detect their falls. If they have some problems, high fever, we can detect it and make automatic emergency calls. Also for exercise and stuff like this. This was our test, and then later it became a product in northern Italy. I also worked together with an industrial designer from northern Italy. You know, the Italians have one of the best designers in the world. So we brought in from my chair the technology and the designer, Mr. Tersariol. He designed, and he's a pretty good designer. He got a Compasso d'Oro award. Maybe you know, it's a very difficult award to get in Italy because they have a very big competition in industrial design. So here you don't see the embedded sensors anymore, so people can live their life and we can detect any kind of health emergencies. We can be preventive, actually. That's a big thing if you are preventive. It's a little bit like a robot, you know. In a robot you have sensor too in real time, and then you give an alarm so no accident happen or no health issue happen later. Okay, and then there are some spin-offs from the chair, like a Kevaso for scaffolding assembly, Nova Spray Tech from Dr. Pan for interior painting, and also Credo Robotics from Dr. Lenner, who is now professor in Regensburg. And here you see the Nova Spray Tech. Before Dr. Pan did a robot for Hong Kong for the facade painting, and now he does for interior painting. And also Dr. Hu, he is here from Kashima. He is now editing a special issue on smart city. So please talk to him, and you can contribute to this special issue. And yeah, so talk to Dr. Hu, you know him, and please contribute to this special issue, Smart City. And what else is, okay, what I think is important, because I study both architecture, civil engineering, and robotics, we have to integrate it. We architects, especially in France, since you are in France, there's École des Beaux-Arts, which is very extreme, and then you have École Centrale with Gustave Eiffel and all these famous people. And then the infrastructure people, we have to also think it together, you know, that's very important. But it's very difficult to bring the two worlds together. But I think, therefore, I think we need a new approach. Maybe we need a revolution. So it's your task to start the revolution in construction. And yeah, that's my appel to you. And I hope you can make it in the future. Do it better than I did it. That's your task. Okay. So, and buy these books. Okay. Thank you very much.
Thank you so much. So we have some. So we have time for a couple of questions, please. We have two persons. We have Marina, you can, and Sofiane, please. Any question? Just raise your hand and present yourself, please, Sofiane. Can you present yourself, please, and ask the question? Thank you.
Germany, for example. But it's very difficult, especially nowadays. Don't sue me for political incorrectness, but what I experienced, because I was in Texas in the 70s, and when I came to Texas the first time, because I had some friends there, the companies like Zachary, you know Zachary, San Antonio, you know, somebody knows? It's a very innovative, used to be very innovative company. And they were the pioneers in prefabrication in Texas, and they did the first three-dimensional concrete modular. They even marketed internationally, called Concrete Modular International. And what happened then is, later, when I was in Chicago and I visited my friends in Texas, I found out that suddenly they scrapped all the machinery, which they had in the 70s. What happened? What happened to your nice factory? And even they didn't have their own machinery anymore. They borrowed the machinery, and they employed temporary workers a lot. And I think this is the problem. Once you employ temporary cheap labor, and then you don't invest in technology anymore, because you just look at short-term return on investment very fast. And I even watched the construction site, and the foreman said to the workers, he was very brutal: you don't need to show up tomorrow if they didn't work properly. So people employed from day to day sometimes. And they called them, it's politically incorrect, wetbacks, coming illegally over the Rio Grande. I'm sorry to say it, but in the 70s, they talk about this problem. In the 80s too. And in Germany, the same mistake happened. We used, after the Berlin Wall came down, we used cheap labor from East and Southeastern Europe and so on. So once you have this labor available, it's okay, we can employ them, but at the same time, we have to advance and develop something to be more efficient. Otherwise, society is stagnating. Like we have the problems now. Now the problem's really accumulating. I think you live in the West Coast, or right? Yeah. Okay. You know the prices, the real estate price is crazy. You know, it's crazy. I couldn't afford it there. Live there where you live, probably. And what you can tell the people is the only thing I can tell, there is so much money actually available. So we have to look at the long term, how the vision of the long term development of the society, because the money is actually here. We have to convince the people cross industries, not just in the construction sector, real estate sector. We have to get the people from all the industry together. That's what I mean. I talked to the mechanical engineering people in Brussels at the European Commission that we need to do something. So this was really critical, because mechanical engineering people professors didn't even like me. They say, why do you get into mechanical engineering? You are a civil engineer, you're an architect. Do your business, don't come into mechanical engineering. That's our business. You don't need to develop any machines, any robots, nothing. Just do it as your other colleagues do it. So it's really difficult. So we have to break up this. So how can you convince investors? It's really difficult. We need also some political assistance. Sometimes even if you have too much money, it doesn't help either. I know they got money from Swiss in ETH, so they got 5.8 Swiss francs because I wrote the recommendation. I know the background. So it's good that they got the money, and I helped them to get the money. But later what they did is, okay, aesthetically it looks good, but also what's going on in Stuttgart, aesthetically looks good, but there is no new kind of robotics breakthrough. So we need a kind of revolution, like when the car came up, you know, from the horses to the car, or when the first airplanes had been developed. This kind of, there was this, also Jean Prouvé, another of my favorite, next to Gustave Eiffel. Jean Prouvé, I learned a lot from him. I went to Paris, I analyzed the Maison du Peuple in Clichy. This was the first building built in light metal steel, and he was friend with Marcel Bloch. Bloch was the original founder of Dassault. Now it's called Dassault, aircraft manufacturer. So he got ideas from Marcel Bloch to do the lightweight thin steel construction. Also, he was friend with Citroën. Same thing. And he did the revolutionary Maison du Peuple in Clichy in 1938, and the first welding in Europe already 10 years earlier. And we need this kind of breakthrough. But I don't know how to do it. We have to talk to politicians. We have to talk to bankers. And we have to convince them for the society of a long-term strategy. And when I talked to, I was invited a lot to China too and to Russia too before. Now it's difficult to go to Russia, but some of these societies have a long-term vision, like a 5-year plan in China. We shouldn't copy everything from China, but something we need this long-term vision. And so we should maybe do some combination, long-term vision, the government has to support it, and then introduce without doing the same system like the Chinese doing, a political system, or the Russians are doing, but something they have is not so bad. Like they have this long-term visions like prefabrication in Russia, just the implementation was bad. But actually the political aspect, the long-term strategy is pretty good. In our societies, like in the United States and Europe, Western Europe, we are too short-term oriented. So we need this kind of long-term vision with politician and industry, cross-industry sector, and also the university have to change because you have to fight with mechanical engineering department, electrical engineering department, and computer science. I have to stop, sorry.
No,
Okay.
Have another question, please.
Yeah. Yes, Amin Hamad from Concordia University in Montreal. Thank you very much for the excellent presentation. My question is in line with the previous question, and maybe more specifically, what do you see for the future? How you extrapolate and how fast this revolution will be happening? And if you see some push from outside the construction industry, maybe from tech industry.
Oh, that's difficult because actually, I'm sorry if I know people from Takenaka and Kajima is here, but I used to have a part-time job for Shimizu Construction Research Institute, and every 6 months we did a new robot. This was really fast. It was only a team of 30 people from all the disciplines, and every 6 months we came out with a new prototype. This was really good. So the cycle can be very fast if everybody is focused and open. And it was new development. It was not just to take an industrial robot, put it on some platform, and then use it. That's a piece of cake, and it doesn't work on the long term on the construction side. But we really developed new kinematics each 6 months. Tuck, tuck, tuck. It was really fast. So it can be done very, very fast. It was only 30 people those days in the 80s. And if you have 300 or more, or I visited an institute in China, it was 3,000. You could do a great job if they work together properly, but sometimes it's also a management problem. Yeah, and then I think it can be done very quickly. So once the political will is there and the spirit of something new, maybe you shouldn't follow all the trends. So maybe you should be very critical. Like I was always very critical, even as a student, what the professors were teaching. So I went my own way. So you always have to question what you're doing yourself and not just follow the mainstream, not just follow what are other people writing about or researching about, or who cites me, or do I get cited if I write this? Actually, I never care for it. Actually, I never wanted to do a doctor and I never want to be a professor, but it happened anyhow. I actually rejected my first offer to get a Robert Bosch scholarship in Stuttgart, because this is prestigious, you know. If you would like you reject Renault or something, Alstom or something in here, scholarship, I rejected. First time I said, no, I'm fed up with the university. And then later I did my doctor anyhow, but in Tokyo. So it shouldn't be about some degree. It shouldn't be about how many papers you are published or whether you are cited or not. You shouldn't care. You just have to develop something new, your own idea, and don't be afraid of people if they don't like it. You shouldn't care, you know. I did the same thing. I didn't care. I just went my own way. And I think if you have your own way and your own originality, you can be successful. I can only say this, I'm sorry.
First question, please. Yourself, please. And another question there.
Hi, this is Yijian Huang from ETH Zurich and from Switzerland. Thank you very much for your talk. I'm interested to your in your presentation. You present a lot of modular robots, especially you just mentioned that every month or so you have a new kinematics, new modular robots. But this is great, but you know it's very hard to have a shared platform for other researchers. Like you're in the Kajima, for example, you have your own robot, but it's very hard to replicate somewhere else, especially for people working on control and algorithm. So I want to see your opinions on, recent progress in humanoids and quadrupeds, like where people have a shared platform. like a mobile robot platform. So I want to see your opinion on this type of development, like, going for mobile robots on site, rather than having everyone have their own design of the robots. What about having a shared platform so people can kind of all contribute and then modify so that we can accelerate the deployment?
Thank you.
I don't know much about the shared platform, but I knew a famous professor. His name was Ichiro Kato from Waseda University. He did the first walking robots called Waseda Leg, Wabot. It was the first humanoid robot in the 1970s. He already started in the 1994 or 5. I think it was the expo in Tsukuba. The humanoid robot was playing real time with an orchestra. So it was really advanced humanoid robot playing piano with an orchestra. He had to adjust to the orchestra speed and whatever, and the conductor. So I think you can do it, but I think it's difficult if the robot does the same thing as the human. This was just my experience. Maybe now IT advanced so fast, maybe you can be successful, but my experience was, therefore I talk about the ecosystem, and I think it's better to do it for the construction industry, and not just for that it copies the same thing what the human is doing. But it's my experience because I grew up when the computer performance was very bad. It took me 1.5 years to program Fortran 77. So you can imagine, and it did nothing much actually. So the performance was very bad. So therefore I would think I would rather do some new kind of ecosystem, like I mentioned. I'm not so, I think it's very difficult for humanoid robots to work on the construction side. It's my opinion, but of course it might be possible and might successful, but I rather would not go in this direction. I would rather develop some other things like I don't like the stuff I showed, or some kind of integrated system. And later it can also disassemble. It can become a living transformer, for example. The building could be a living transformer, and then it would never be torn down. It can reconfigure itself, and this would all be the living machine, machine habitation, some other famous Swiss French person, Corbusier, or something like this. Something different. Okay, humanoid is nice. You can try, but if the computer power is big enough, maybe it's possible. If you have huge data banks, but I'm just imagining huge data bank, artificial intelligence. Okay.
Thank you.
It works on the construction side, I'm not sure about it. Or digital twins also, but it must be real time. Maybe a little bit like an airplane pilot. If an airplane has an automatic landing system or this kind of technologies, then it makes sense, but you need it in real time. Once you find out it has been built wrongly, on the construction side, it's too late. It must be real-time control, so it works on the first time. It doesn't help if you realize later that it was built wrongly, and then you sue each other and stuff like this. So it should be done in real time, and then you can have this kind of digital twin, maybe the big opportunity to use the potential of digital twins if they're real time. Almost real time. real time never happens, but almost real time. So you don't make a wrong construction process on the site, because then it costs money to rework. It's better to invest before, because redoing costs more money in the end. Oh yeah, this would be an argument actually. Redoing it costs more than doing it right the first time. Just wait, prepare well, good job preparation, and then it's cheaper. This maybe for the investment question before, and then you don't spend money on the rework.
Thank you, Thomas. The last question, please. No, you keep it. The last question. Can you present yourself, please?
Yeah. Hello, my name is Orsolya Heidenwolf. I am from Budapest, Hungary. And I would like to ask about what is your opinion about the country, specific countries' digital readiness? I mean, let's say using building information modeling and the mindset of construction robotics. Because, for example, in Hungary, government initiatives, they said that we are even not in the level of high-level building information modeling, so that's why we are not focusing on construction robotics. So what do you think? Is it like there is correlation between this, or we need to start focusing now for construction robotics?
Thank you. It's for you. I think so.
Well, I think it's a big potential. I mean, even if you don't have it now, you have all the chances to shape it. I know some old Hungarian professor, Sebastian. He was a pioneer in lightweight construction, a little bit like Jean Prouvé in France. And I know the old education in Hungary was very good in mathematics and physics and the basic science. So this is a very good basis. And then you can systematically develop this new ecosystem, especially if it's sometimes in Germany, for example, we already have an established industry. Sometimes it's more difficult to change an established industry. And if you still have the possibility to shape it from the beginning, and then I think you have more chances in the future and can take over even some advanced countries in Europe. But it's difficult depending on the investment too, and the will, the political will.
Thank you so much.